Hi, my name is Kyle Hubbard, and this is our problem on Newton's laws. So, the problem is, fluffy dice are hanging from a rearview mirror. Find the acceleration of the car using the angle of that the massless string makes with the vertical. Assume that the accelerations of the string and the car are equal and constant. Also, the system is in a state of equilibrium in the y direction. First, we're going to start off by going over to the drawing here. Here's the dice, and this is pointing towards the ground. So, to go about finding this, you have to start off by finding tension, which you're going to have to draw in our free body diagram, which shows what forces are acting on the object we're analyzing and which direction. So, tension's going to be going up that way, the way of the string. And then the other force acting on this is gravity, so we're going to have an mg down here, which will be that force of gravity. And another important thing of the free body diagram is the coordinate axes, because it tells you how to break up things into components and what their signs are going to be. So, since tension is angling that way, we have to find it. We have to find the tension, the horizontal component of tension. So first we're going to write Newton's law here, which is, and since F equals ma. And since I said that we're in equilibrium in the y direction, that means that f of y equals to 0. So that's going to mean we're going to use the horizontal component of this to find t. That the horizontal component is equal to t cosine theta. And then it's going to be, we're using the vertical. We're using the vertical component so we can go, because we're doing it in the y direction, so we're using the vertical component. T cosine theta minus mg is equal to 0. And then we're going to use algebra and switch these around. So if you switch it around, it ends up being mg over cosine theta equals t. Alright, so now we found the tension. So in this, we're going to have to use a system of equations. So now we're going to have to go to the, we're trying to find the acceleration in the x direction. So we're going to go to the f of x, sum of forces in the x direction, equals ma. Now this one we can't put as 0 because it actually has an acceleration. It's not acceleration in the y. In the y direction, accelerating in the y direction, that's why we don't put it there. So the x direction, the x component of t is t sine theta, and that's the only force in the x direction there. So t sine theta equals ma. But we figured out t up here, so we're gonna plug it in to our problem down here. So we're going to go mg over cosine theta times sine theta equals ma. And if you do, since this is going to be in here, sine theta over cosine theta is equal to tan theta, so it's going to be mg tan theta equals to ma. Then you gotta cross out the m from each one, and you are left with a equals g tan theta. And if you had all the values, if you had a value of the angle, then you could find the acceleration. And that concludes this problem.